greatest integer function is a step function with a constant step length and a constant step height. In this video, I'll show you how to graph the greatest integer function using parameters a, b, h, and k. But before we go any further, let's review the role that each of these parameters plays. Generally speaking, the rule of a greatest integer function is f of x equals a times greatest integer of b times x minus h in brackets plus k. Parameter a is the vertical distance between two steps and is called the step height. Since distances are always positive, we refer to the absolute value of a, meaning its value regardless of its sign. Parameter b determines the length of each step. To calculate this length, we divide 1 by b. Once again, since the length is always positive, we use the absolute value of this calculation. Parameter b also influences the orientation of the steps, but we'll come back to this later. Parameters h and k represent the coordinates of one of the closed endpoints of the function. Since there are several closed points, there are several possible hk pairs for the same graph. When graphing a greatest integer function, use h and k as the starting point. Let's graph the step function f of x equals negative 1.5 times the greatest integer of x over 2. Before starting, let's identify the 4 parameters. We'll write this important information in the table so you can graph the function more easily. Here, a equals negative 1.5. To determine the value of b, you need to write division by 2 another way. Dividing by 2 is the same as multiplying by 1/2. Inside the square brackets, there is now 1/2 times x, so b is equal to 1/2. The values of h and k are 0 and 0 since there are no other terms inside or outside the square brackets. Start by finding the starting point, whose xy coordinates correspond to h and k. In this example, the point is 0, 0. Next, we need to work out the step height by calculating the absolute value of negative 1.5, which is 1.5. This means that there is a distance of 1.5 units between each step. We continue by finding the step length. To do so, we calculate 1 divided by 1/2 as an absolute value. The division can also be written this way. Since this involves dividing by a fraction, change the division to multiplication and invert the fraction on the right. This gives 1 times 2 over 1, which is 2. Since the absolute value of 2 is 2, we know the step length is 2 units. Now we need to figure out the orientation of the steps. Will the steps have a closed point on the left and an open point on the right, or the opposite? It all depends on the sign of b. If b is positive, those steps are correct, but if b is negative, it's the opposite. In this example, b is positive, so the steps have this orientation. The last thing to check is whether the function is increasing or decreasing. If a and b have the same sign, the function is increasing. If they have opposite signs, it's decreasing. Since a is negative and b is positive, the function is decreasing. The function can now be graphed on the Cartesian plane. Let's place the starting point at 0, 0. The steps are 2 units long and look like this. From the closed point, move 2 units to the right and place an open point at the very end. The next step should be 1.5 units straight up or down. Should it be placed like this or like this? Since the function is decreasing, this one is correct. When graphing the next step, make sure that each closed point is opposite an open point. Do the same thing for the next step. Let's place it 1.5 units higher. At this point, we don't have much room to continue upwards, so we'll continue the graph downwards. Place the next step here. And here. It doesn't matter if the last step doesn't fit completely on the graph. There you go. We have graphed our first greatest integer function on our Cartesian plane.